Hello everyone, very good evening. Welcome to the BYJU'S exam prep. This is Sanjay Rathi. How are you guys? Now this is third session on questions from Sadiku chapter 3 methods of analysis. Okay. Okay. 1 minute. Everything is fine. Okay, I think everything is fine now. So everyone, now we will solve some important numericals from this textbook, that is the methods of analysis chapter 3, Alexander and Sadiku, fundamentals of electrical circuit. I think you have the 5th edition of this book. I am having this edition. This is in front of you. I think it is visible to you everyone. Now some important numericals on this topic. So very good evening Kumar, how are you? So ask your friend to join the session everyone. Now to chapter 3, already I have done questions from chapter 1 and chapter 2, some important selected numericals from practice as well as from what unsolved numericals, and I have uploaded the PDF of those session on my Telegram channel, that is Electronics by Sanjay Rathi. So Das, very good evening, and T. Achume, again very good evening. Now this is my introduction. Myself Sanjay Rathi. I am having almost 23 years of teaching experience and I have qualified and selected for engineering services exam that is conducted by UPSC, and these are my ranks 16 and 21, and I worked as deputy director, and then I have trained more than 1 lakh students through offline classes mainly and through online classes. Okay, then this is my Telegram channel. If you want the PDF of this session as well as daily important questions, information about the exam, then you can join. That is Electronics by Sanjay Rathi, or so that you are not going to miss any class, because I will upload the notification of my class on this channel. And before starting the session, this is very important information for you. National Scholarship Test for GATE exam, that is on 22nd of October, means this Sunday. This is the coming Sunday. 9 AM to 9 PM means window will be open for 12 hours. You can give the test at any time, but you have to register it for now, right? Just you can register here. And then second one, detailed preparation strategy to SGATE 2025 by Richa Gupta ma'am on 25th of October at 7:30 PM, live free workshop. Register here for this workshop also. And guys, this is a golden opportunity for you. Get up to 90% off on our program. Guys, first question. Okay, सर डिपेंडेंट सोर्सेस सॉल्व करने में थोड़ा कंफ्यूजन हो रहा है, हाउ टू डू. नाउ टुडे वी विल सॉल्व अराउंड 5 to 6 क्वेश्चन ऑन डिपेंडेंट सोर्सेस. ओके, KCL and KVL. That's why I have started with what very basic. Today we will solve some questions on dependent sources. Then after that, give me feedback. Shreyans Verma, how are you? Now, and everyone use your copy pen and calculator like this. Copy, pen and calculator. This is the rough copy. Then use your virtual calculator. Okay. Now calculate the mesh currents I1 and I2 of the circuit. Suppose it is a very basic question on mesh current. Sometimes we are having this type of diagram. Then we have option to solve this type of question by using the mesh analysis. So I1 and I2. So what is the mesh current? How we can solve this particular question? You have to find the I1 and I2. Both the currents are in clockwise direction. Then watch this. I will give you method how to write the equation. Then you have to solve the equation by using the Cramer's rule or by using any other method. Then first question. Okay. Now this is I1. We are just mesh analysis means this is a mesh, this is a mesh. These are called mesh current. And then guys, you have to write the KVL here. This is the minus 45. 2 into I1. And what is the current in downward direction? That is the I1 minus I2. It is in upward direction, it is in downward direction. So what is the current? I1 minus I2 in downward direction. So what we are writing, plus 12 times of I1 minus I2. And then 4 times of I1 and that is equal to 0. Then you will get 2 plus 12, 14 plus 4, 18 I1. 2 plus 12, 14 plus 4, 18 I1 minus 12 I2 is equal to 45. And that is the equation number 1. Now, second, write down the KVL in this loop. So you will write 9 I2 plus 30. Proper KVL, this is plus, this is minus, that is plus 30 plus 3I2. This is the mesh current I2. And now, what is the current in upward direction? Watch this. What is the current? This is the current in downward direction, but what is the current in upward direction? I2 minus I1. Normally we are writing this is the plus, this is the minus. So I2 minus I1 into 12. We are writing in respect with respect to what? I2. So you will write 12 times of I2 minus I1 because in upward direction current is I2 minus I1. So we are writing the KVL. This is the KVL. Okay. Now 45, 30 volt. This is the first equation. Now what is the second equation? Is equal to 0. Now watch. This is 9 plus 3, 12 plus 12, 24. 24 I2 minus 12 I1 is equal to minus 30. This is the minus, this will become minus 30, or you can write like this. Plus 30 is equal to 0, and shift that, so you will get a 12 I1 minus 24 I2 is equal to 30. Change on the right hand side, it will become 30. That is the equation number 2. Now you are having the two equations. First of all, can we make it easy? Because in GATE, in competitive exam, we will get the less time. Yes, directly you can use the inspection method. So what is the inspection method here? Inspection method. Means what? Directly you can write. Now in this loop I1 will flow through the 2, 12 and 4. So 12 plus 2, 14 plus 4, 18. So directly you can write 18 I1. And then what is the 12? 12 I2 will oppose I1 because I1 is in downward direction, I2 is in upward direction, and which register is common? 12. So directly you can write minus 12 times of I2. And this battery will deliver the energy. How we can say? Because I1 enter through the minus, leave the plus. So directly you can write on the right hand side 45 degree, 45 volt. So watch this equation. So you can remove this step and directly you can write, and that is called inspection method. You can save your time. Similarly, watch this. 12 plus 9, 21 plus 3. 12 plus 9 plus 21. 12 plus 9 is 21 plus 3, 24. 24 times of I2. Right? 24 times of I2. And what is the I1? Opposite to I2. That's why minus 12 I1. Now the current enter through this plus 30. So on this side you will write the plus 30 is equal to 0. So that is what, directly watch this equation. 24 I2 minus 12 I1 plus 30 is equal to what? 0. And you can write directly, you can remove these steps. And that is what you can save around what? 20 to 30 seconds. Okay. Now, so one student have given the answer. What is the answer given by? 2.5 and 7.5 ampere. Okay, I will check. No. I will check that. Thus, no. This once you have got the equation, then how we can solve this? Okay then. What are the equations? 18 I1 minus 12 I2. 18 I1 minus 12 I2 is equal to 45. Always remember, can we reduce this? Yes, it is divisible by 3. So it will become 6 I1 minus 4 I2 and is equal to what? 15. We can divide it. That is the equation. Then second equation, What is the second equation? 12i1 minus 24i2, 30. 12i1 minus 24i2 is equal to what? 30. Okay, then it is also divisible by what? By 3. That is the 4, 6 and 10, or this is also divisible by or other values. So you can first of all take the common. You can take 6 as a common. It will become 2i1 minus 4i2 is equal to what? 5. Can we write it is divisible by 6, 24, that is the 4 and 30. That is the second equation. Now, we can use what? Elimination method. We can use what? Elimination method to solve this question. So this is the equation number 3 and that is the equation number 4. 3 minus 4. 3 minus 4, equation number 3 minus 4. So 6 minus 2, that will become 4i1. And this term and that term cancel out. 15 minus 5, that is equal to 10. This is called elimination method. So 10 by 4, that is equal to 2.5 ampere. How many students are getting this answer? 2.5 ampere. 2.5. Bhanu, your answer is correct. 2.5 ampere. Now, once you will get the 2.5 ampere, how can we can get the I2? That from you can put in this equation or in that equation. Suppose you are putting in this equation 2.5. Put in 4. Then you will get 2 into 2.5 is nothing but 5 minus 4i2 is equal to 5. So 550. So what is the I2 is equal to 0 ampere. I2 is equal to 0 ampere, and that is the answer for this question. So Shreya, all other students, check your calculation. Okay, well try. You have given the right answer. But why? Because in exam hall we are doing the silly mistake. Same type of why we are getting the wrong answer. This is a very simple equation. Very simple equation. Okay. Okay then. Comfortable? All are comfortable with this method? Next question. These are the answer. Very simple mass analysis. Or you can use what? Inspection method. But you have to practice 2 or more questions, so that you will become comfortable with this method. Okay, that is very important. Directly we can write equation. Then next one. Next question is, watch this. This is the question with dependent sources. So students are worried about the dependent sources. Don't think about this. Simple mesh analysis. Using the mesh analysis, find I naught. And here I naught, it is a dependent source. Okay, and you have to find the I naught. This is the I naught. I naught is this is the branch current, and on this branch current, this is a current control voltage source. This is a current control voltage source, and you have to find the I naught. Quickly write the equation, and that is the again unsolved numerical from what? Sadiku, Alexander and Sadiku. Okay, then this is the figure number 3.21. If you have the 5th edition, then you can watch. Then using mesh analysis, find I naught in the circuit. What we can do? Mesh analysis it is given because we want to use the mesh and nodal analysis this time. Now I3 is I naught. Watch this. I3 is nothing but I naught here. Okay. First equation. And that's why if I3 is I naught or I naught is I3, then you can write it what? 10 I3. 10 times of I3. Then if we are using the inspection method, then it will become 4 plus 2, 6. First KVL. In first mesh, 4 plus 2, 6 I1. Be careful about it. What is the I3? I3, it is moving in the right to left in this branch, and I1 is moving in opposite, and that's why it will oppose. So it will become minus 4 I1. Similarly, I1 is moving downward, I2 is moving upward. It is minus 2 I2. Minus 2 I2. Minus 4 I1. I3. Minus 4 I3. And what about this? Since this is the negative, watch this. This is the negative voltage. When we are entering through the negative, this is plus. This is plus. When we are negative, minus 16. here it is minus 16. So on the right hand side it will become what? Plus 16. So directly you can write plus 16, or that is the first equation. So 6i1 minus 2i2 minus 4i3 is equal to what? 16. Now you can take 2 as a common. So it will become 3i1 minus i2 minus 2i3 is equal to what? 8. Make it as simple as possible. Then this is the equation number from the inspection method. Then second one. Second question is, the second mess is this one. Watch this. Now again inspection method, 8 plus 2, 10i2. Now watch this. This is the 10i3. Already I have written I0 is i3. Then what is this? I3 and I2 are in opposite direction. I1 and I2 already in opposite direction. Then you can write minus 2I1. This is the minus 2, minus 8I3. And since it is entered through the minus, this is the minus 10 times of I3 is equal to 0. That is the rule of the dependent sources. Then guys, what is this? 10I2 minus 2I1 minus 18I3 is equal to what? 0. Now again you can take the 5 as a common. This will become minus 2 as a common. So it will become I1 plus 5I2 minus 9I3 is equal to 0. This is the second equation. Okay. Then third one in this loop. So what is this? 6 plus 4, 10 plus 8, 18I3. And what about this? 4 is opposite direction. So minus 4I1 minus 8I2 is equal to 0. And then again you can take 2 as a common. Then it will become minus 2I1 minus 4I2 plus 9I3 is equal to 0. And that is the 3 equations, 1, 2 and 3 after taking common. If there is any calculation mistake, then please inform me. Okay. Then one student have given the answer, good one, Vishwajit Nayak. I will check what happened. Okay. Okay, we can, no, one by one I will give now, because Harshvardhan, you can also use the nodal analysis for this question, no problem. If you are getting the answer, tell me what is the answer. It's up to you. Now you have given the answer. I have to answer what is the I0. Vishwajit, I0 is required. I0 is what? I3. I0 is what? I3. I0 is I3. Okay. Then, tell it. I will check, then I will inform. Okay, minus 4, Kumar, you are getting minus 4 exactly. Then watch this. You can we use the Cramer's rule here? So, okay, first of all, write down the equation. First of all, write down all the equation. The first equation is 3I1 minus I2 minus 2I3 is equal to 8. That is the first equation. Second equation is minus I1 plus 5I2 minus 9I3 is equal to 0. Third equation, minus 2I1 minus 4I2 plus 9I3 is equal to 0. These are the 3 equations. Now you can arrange 3 minus 1 minus 2, 3 minus 1 minus 2, minus 1 5 minus 9, minus 1 5 minus 9, minus 2 minus 4 9. This is I1 I2 I3 is equal to 8 0 0. Okay. Now because we have to find the I3 only, then what is the determinant of this? Determinant of this is 3 into 5 into 9, that is the 45. 9 into 5, 45. And minus minus plus again will become 9 into 4, it is what? 36. Okay, then this is the minus minus, it will become plus. 1 into minus 9. This is minus 9. 9 into 2, 18 plus minus 18. Then it is minus 2. I am just finding the determinant of this. 1 into 4, 4. And 5 minus 2, that is the minus 10. It will become plus 10. Okay. Check my calculation also. 45 minus 36, that is 9. 9 into 3, 27. Minus 27. Minus 28. I am getting minus 28. Is it correct? Check. Now, that is another way. Just I want to give the idea about the Cramer's rule. Now, only we want what? Only we want I3. That's why this third column you can replace by what? 800. So, what is the del 3 here? 3 minus 1 minus 2 minus 1 5 minus 9, and that is minus 2 minus 4, and you have to replace this third column. So remove this. In this place you can put the 800. Right? Now watch this. When we are taking this is the 0 multiply 0 khatam, finished. Then we have to find only this one. So what is this? 8 into, this is the 4 plus 10. Then this is the 14 into 8. This is del 3. Now tell me, this is the 28, that is the, please calculate the value. So this is the del 3 upon del. What is this? 8 into 14 upon what? 28 with minus sign. 2, and I am getting the minus 4 ampere. How many students are getting the minus 4? Now watch this. I have done calculation. I have not solved because it is unsolved numerical. I have just solved in front of you. Right? And then because every step you have to take care. Suppose you are doing the wrong calculation. My dear friend, already we have applied all the concept, but we are getting the wrong answer because we are not able to solve the equations. So it is a very easy way because only the I naught is required, and that's why I have used the Cramer's rule. Otherwise, if your observation is too good, then watch this. Can we add these three equations? Right? Can we add these three equations? If suppose you are going to add these three, because sometimes they are giving a very easy calculation. 3, 3, 3 cancel. This cancel out. Add these three equations. Minus 4, minus 1, minus 5, plus 5 cancel out. So when we are adding all these three equations, 9, 9 cancel out. You will get minus 2i3 is equal to what? 8. And what is the i3 is equal to? Directly you can say minus 4. So i3 is equal to 8 by 2, that is minus 4. But you have to observe the equation. If suppose we are not able to observe the equation, if it is not visible, that if suppose we are going to add all these and we are getting this result, then in that case, very easy method is what? You can use the Cramer's rule for 3 variables. Okay? Otherwise you can solve. Okay, Kumar? Your answer is also correct. Now next one. Minus 4. And check your calculation, everyone. Next one. Next question. Now that is the time for this is the third one. Now this is the super mesh analysis we have to apply. Super mesh analysis. In this question we will use the super mesh so that you will get the idea about that. Super mesh analysis. Then so stay tuned with us and subscribe the channel, because after that I will take session on what? Theorems. Thevenin's theorem. This is the third chapter on basics. First chapter I have taken on basics, then second on basic laws. That is the KCL and KVL, and that is the third chapter on mesh, super mesh, nodal, supernodal analysis. Answer is -4. Okay. Then use mesh analysis to determine the I1, I2 and I3. But just I am going to give you the how to write the equation. Now watch this. We are having one current source between these two meshes. If we are having the current source, we can't write the KVL because we are not having the idea about the voltage across this current source. And always remember, if there is a one resistor connected in series with the current source, then no need to consider it. You can, it doesn't matter what is the value of the resistance. But what is the current in this branch? 4 ampere. And you have to apply the super mesh analysis. So what is the super mesh analysis? Just we are going to write here. And we want 3 equations. To watch this. First equation is, in this branch, this is the downward current. I1 is in downward direction and I2 is in upward direction. So what is the current in this branch? I1 minus I2. I1 downward, I2 upward. So you can write I1 minus I2 is equal to 4 ampere. This is the first equation. I1 minus I2 is equal to 4 ampere. Now, for this loop and for this, we have to apply the super mesh. So we are applying the KVL here. Watch this one. Go through this. Go through the highlighted portion. Reach here. And that is, you have to apply KVL, and that is called super mesh. We are just merging the two mesh, this one and this mesh. Then write down the KVL. This is -8 plus, what is this? I1 in downward direction, I3 in upward direction. So what is the current in this branch? I1 minus I3. And that's why you will write 2 times of I1 minus I3. Then here, what is I2 in left direction, left to right, and I3 in opposite direction. That's why you will write 4 times of I2 minus I3. We are moving in this direction, plus minus. Then 8 times of I2. 8 times of I2 and then finished. Okay, that is 0. Then 2 times of I1 minus 2 times of I3, 4 times of I3, 6 times of I3. Okay, then plus 8 plus 4, 12 times of I2 is equal to what? 8. And then remember, this is the equation. You can take 2 as a common. I1 minus 3I3 plus 6I2 is equal to 4. Divide the 2 and that is the equation. First equation. That is the second equation. First and second. Then this is called super mesh analysis. So we have applied the super mesh. We can apply the KVL in closed loop. So this is the KVL. Now this mesh is what? I3 current. So you can apply the inspection method. 2 plus 2, 4 plus 4, 8. 8 I3 minus, because it is in I1 is in opposite direction, 2 I1, and I2 is also in opposite direction, 4 I2. That is equal to 0. Now you can take 2 as a common, so it will become minus I1 minus 2 I2 plus 4 I3 is equal to 0. That is the third equation. 3 equations, 3 unknowns, and then you can find the values, guys. And these are the equations. I1 minus I2 is equal to 4 ampere. Then just, can you solve this? Then now you have to solve all this, right? Then simply by using Cramer's rules or by using elimination method or all other method, and check my equations. I'm just giving you the answer because in previous 2 questions I have given how to Vishwajit, you have given the answer 10,909. Acha. 4.632 ampere I1. How many students are getting? Tell me. 4.632. These are the equations. 1, 2, 3. You can elimination method, you can use 4 plus I2 is equal to value of I1, then replace that, then you will get the two equations, and then you can solve by using any other method. Just I am giving you the answer. Please note this. The first question, I1 4.632. Check this. 4.632 ampere. Then I2 you will find 631.6 milliampere. Means 0.6316 ampere. 0.6316 ampere. And 1.47 1.4736 milliampere. Very small. Okay, that is the value you will find. I think this is in milliampere. Okay. Vishwajit. So that is called a calculation mistake. So in exam, we can avoid all this. So try to solve the complete question at the up to end and get the answer. And what we are doing the silly mistakes, please check. Okay, then next one. Next question is, so a source is also given. Figure number 3.25. You can open your book. Right, figure number 3.25. You have the 5th edition. If you have the 5th edition, this is unsolved numerical, guys. For solved numerical, solution is given. You have to solve the unsolved numericals. Figure number 3.25. You can search. You will get the same question there. And then try to solve this. This is the 3.25. Now, answer it is given. 1.4736 ampere, 0.631.6 milliampere, and so on. Already I have given the answer for these questions. This one. This is last one is in ampere. So how to apply the super mesh analysis? Page number, page number 100. You can dial the page 100 numbers. Okay. The next. अरे अभी तो बनाओ यहाँ, अभी बुक रेफर मत करो, वहीं से आंसर देखकर बता दोगे, सॉल्व करना है. Now guys, already we have solved 3 questions on mesh analysis. Now nodal analysis. So what is the question on nodal? Everyone, Harsh, tell me. What is the answer for Harish? Now, what is your name here? Harsudhan. Okay. Okay, everyone. Tell me. Apply nodal analysis to solve for Vx in the circuit. Now, nodal analysis means what? Simply, suppose one student is worried about that dependent sources. Okay, no problem. If this is 0.2 Vx, this is what? Voltage controlled current source. Voltage controlled current source. This Vx is given and you have to find the Vx. Then tell me what is the answer. This is your reference. This is your reference. Then this is the Vx. Because this is a common node, the voltage across all this node is what? Vx. Now you can apply the KCL, that is called nodal analysis. So incoming is equal to outgoing current. Now what are the outgoing current? This is the I1 is the outgoing current, I2 is the outgoing current, and this is also I3 is the outgoing current, and this is the incoming current. So 2 is equal to I1 plus I2 plus I3. These are called outgoing current. So what is this 2 incoming? What is the I1? Vx minus 0 by 10. That is Vx by 10. I2. Vx by 20. Vx by 20. And what is the I3? 0.2 Vx. 0.2 Vx is nothing but Vx by 5. 0.2 Vx is nothing but Vx by 5. Now you can take Vx as a common. Inside the bracket 1 by 10 plus 1 by 20 plus 1 by 5. That is 0.2 is written as 1 by 5. Now you can take 20 as a LCM. Then it will become 2 plus 1 plus 4. That is 7. And then what is the Vx is equal to 20 into 240 by what? 7. Is it correct? What is the 40 by 7? What is the 40 by 7? Check. $5.714. Yes, this is the correct answer. Easy? Okay then. So simple calculation. So don't worry about the dependent sources that depend upon this. Already we have solved. We have to solve the Vx. Simply write down the KCL and then you can find the value. Okay then. Next one. This is a simple nodal analysis. Now again, question on dependent, number of questions based on what dependent sources. You can solve number of questions from what Sadiku. Once you will be comfortable, then leave it. No need to solve all the questions, but try to solve as much question as possible. जब आपको confidence आ जाए कि हाँ भाई मैं एग्जाम में बना लूंगा, तब छोड़ दीजिए. पूरे क्वेश्चन बनाना जरूरी नहीं है, उतने बनाओ जिससे आपको कॉन्फिडेंस आ जाए. Determine the IB in the circuit. Where is the IB? Now IB. Now this is the 60 IB, this is the 150, this is the 50, this is the 250. Now guys, if you want to IB, then can we what is mesh analysis or nodal analysis or any other analysis? Tell me what you want to apply. What you want to apply? Mesh analysis or nodal analysis or any other method? This is the question number 3.9. Means it is an unsolved numerical. It is a unsolved numerical from the practice. 3.9 means this is the unsolved numerical. Directly go to the practice session. At the end, number of questions are there. And we have the answer for all the odd number questions. Right? So at the end of the chapter, this is called what? Problems. And this is the problem number 3.9. Okay, and then this is the problem number 3.9 and answer is given on the page. This is the page number 115 and answer is given on the page number 822. 822, that is the okay. Now watch this. Because you want IB, this is let I1. This is I2. You have to find the I1 because I1 is IB. Directly you can write inspection method. This is the minus 24. 250 plus 50. 250 plus 50 is what? 500 I1. 250 plus 50, 500 I1. Minus, because it is in opposite direction, 50 I2. Then you will get 500 I1 minus 50 I2 is equal to what? 24. That is the first equation. You have to find the I1, that is the IB. Now in this loop you can apply the 60 IB. This is the KVL 60 IB. IB is nothing but I1. So directly you can write the I1 60 I1 plus 150 plus 50 200 I2. Directly write 150 plus 50 and what is I1 in the opposite direction? Minus 50 I1. 50 I1 is equal to 0. Then you will get 10 times of I1 plus 200 I2 is equal to what? 0. Now you want to find the I1. So what is the I2 in terms of I1? I2 is equal to minus 10 divided by 200 I2. I1. Minus 10 divided by 200 I1. So you will get minus I1 by 20, that is 0.05. I1 by 20 means what? 0.05. Now you can put this value in equation number 1. So it will become 500 I1 minus 50 minus plus, it will become plus by 20 I2 is equal to 24 I1. This is the replaced I1. Now this is 2.5, 500, 2.5. So what is the I1 is equal to 24 divided by 502.5. 502.5 guys. Sir, I have made a mistake. Where? 250 plus 50, that is the 300. 250 plus, okay. I have written what? 500. Oh, sorry. Sorry. Now all the answer is wrong. No? This is the, hey, 1 minute. Minus 20, 250 plus 50 is, this is called silly mistakes. This is the silly mistakes. And now all the answers, this is the 300. Yes. This is what? Minus 24, that is equal to 0, and then you can solve. Yes, that is my mistake. And the next time I think I have written a saying, okay, 150 plus 200 minus 50, okay, everything is fine. Then this is, I have taken common. This is also correct. No, this is wrong. Now put these values, it will become 300 I1 minus plus 50 by 20 I2 and is equal to what? 24. This is I1. Why? Because I2, I have replaced this I2. I have put this value of I2 in equation number this 1. And then this is nothing but 2.5. So I1 is equal to 24 upon 302.5. 24 upon 302.5. So you have given the 79.34 milliampere. So 24 divided by 302.5, that is 0.079333. So it is ampere, multiplied it by the 1000, you will get the 79.34 milliampere. milliampere. Is it okay, everyone? So this is the calculation. So not, I have done mistake, yes or no? In front of you, I have done mistake. Now tell me, it is a conceptual mistake or it is a silly mistake? How we can say, sir, 250 plus 50, how it is 500? Tell me, what is 500? And just we are doing this type of mistake, and how we can avoid all these? Tell me. It is never ever possible to avoid 100% mistakes, but we can reduce it. Meditation. थोड़ा सा meditation करो, थोड़ा ध्यान लगाओ जब question, when we are solving that particular question, don't think about the other things. Okay. But at the same time, no, practice is also important, and meditation, because at the same time I am reading your comments, I am going through the textbook, which number, and I am going through what page number, on which page the question is available, and because of that just we are doing silly mistakes. But you all are what? Students. Simply focus on question. और पूरा काम रहना, पूरे क्वेश्चंस, इक्वेशंस प्रैक्टिस करो, बार बार प्रैक्टिस करो, किस टाइप की मिस्टेक्स हो रही है वो ध्यान रखो, and then we can avoid these mistakes. Okay then. Now this is the answer. This is on the mesh analysis. We can solve this type of questions by using the mesh analysis, or you can also solve by using the nodal analysis, guys. Yes, you can solve by using the nodal analysis. Then next one, this one. Obtain the node voltages. Now this is a very easy question, but some students are doing mistake. That's why nodal voltages. Node voltages in the circuit of figure. Then what is the answer? Figure 3.4. Figure 3.4, what is the value? Quickly give me the answer, everyone. Just I want answer. V1 and V2. Then this is the incoming current, and some students are confused with this. That's why, watch this. Suppose it is a nodal voltage V1. It is a nodal voltage V2. And what is the incoming current? 3. Always remember, for this node we are writing just I1 and I2. For this node, focus on this node only. So what is the incoming current? 3. What are the outgoing current? V1 minus 0 by 2. That is the practice. V1 minus 0 by 2. V1 minus V2 by 6. V1 minus V2 by 6. Now you can take 6 as a LCM. It will become 18. This will become 3V1 plus V1 minus V2. This is the 3V1 plus V1 minus V2, and that 6 is multiplied here, 18. Then you can write 18 is equal to 4V1 minus V2, and that is the first equation. Okay. Now when we are writing the nodal for the second, so which one is the hero for this node? V2. Then what we are writing? what is this current I1, what is the outgoing current I2, and what this is also the outgoing current. So I1 plus I2, this is for the second node. I1 plus I2 plus what? 12. I1 plus I2 plus 12 is equal to 0. What is the I1? V2 minus 0 by 7. That is V2 by 7 plus V2 minus V1 by what? 6. Right, plus 12 is equal to what? 0. Now you can take 42 as a LCM, then it will become 6V2 plus 7V2 minus V1, 7V1, and that is, because it is a 12 into 2, that is the 24, 12, 4, 48, 504 is equal to 0. This will become 0 and you will get 7 plus 6, 13. You will get 7V1 minus 13V2 is equal to 504. And that is the equation number 2. Now we are having the 2 equations and 2 unknowns. Then you can solve it. You will get the answer. So Harshvardhan, what you are getting is minus 6 and minus 42. Yes, the answer for this question is minus 6 and minus 42. So just I have written the equation, how to write the equation, guys. And that is minus 6 is the value of the V1 and minus 42 is the value of V2. Solve these 2 equations. Okay. All are comfortable with these? ओके तो सॉल्व कर लीजिएगा. तो हाउ टू राइट द इक्वेशन एंड जस्ट सॉल्व इट. ठीक है ना, ऐसा नहीं कि छोड़ दिए हो जाएगा सर करके. देखो यहाँ पे इतनी मिस्टेक होती है तो हो जाएगा वाला नहीं. ऑलवेज ट्राई टू गेट व्हाट लास्ट आंसर. नॉर्मली व्हाट वी आर डूइंग, वी आर जस्ट ना reading the books. Okay, I am able to solve this question during exam. I can solve this question during exam. But we can't avoid the mistakes. So suppose we are solving on rough pages, then yes, because this is a very easy calculation. This equation, that equation, already we have the answer. So you can use the 2 or 3 methods to solve the equation by using the Cramer's rule, by using the elimination method, or for example, it is the 13V2, you can multiply this equation by the 13 and then subtract these 2. You can eliminate the V2, you can directly find the V1. Once you have the V1, you can directly, right? Or simply you can divide this equation by what? 4 by, you can multiply this equation by 4 by 7, and that is the method. You can use any type of method. Okay. Now, next one, answer is minus 6 and minus 42. Then, 1 minute, just we want to solve one question by using the super mesh analysis. This is the, yes, this one. V and I in the circuit of figure. This is called super nodal analysis, not mesh, super nodal analysis. Sir, source conversion takes less time. Source, you can use source conversion, but where I have given the source conversion? In the previous question. Okay. But we have to find the nodal voltages. Now, what is asked in the question? What is asked? If suppose you are going to transform the source, then how you are going to find the voltage at that particular node? Already when we are changing the source from current source to voltage source, then what about that particular node? In that question, node voltages is required. Source transformation we can use when current through any resistor or current voltage across any resistor is required. Okay. Now, find the V and I in the circuit of figure. Find V and I in the circuit of figure. Okay. Now, here you have to apply what? Super nodal analysis. Super nodal analysis. So, what is the super nodal analysis? Watch this. Now, means you can choose, this is the V1, this is V2. Let these two are nodes. If the V1 is nothing but V, and what is the I? V2 by 2, and that is the reference. Now, super nodal means, because we are having the one voltage source between these two, that's why we can't apply the KCL here. this V2 minus V1. Always remember this is plus, this is minus. That's why we are writing V2 minus V1. If suppose this polarity is plus minus, then we have to write V1 minus V2 is equal to 6. So this is V2 minus V1 is equal to 6. That is the equation number 1. Then what is the super node? Then apply the KCL at this point and apply the KCL at this point at the same time. For example, this current is like I1, this current is I2, this current is like I3, this current is I4. All are the outgoing current. So what is the meaning of the super node? I1 plus I2 plus I3 plus I4 is equal to what? 0. From this I1, this is I2, this is I3, this is I4 is equal to what? 0. Now how we can write the I1? V1 minus 14 by 4. V1 minus 14 divided by 4 plus I2. V1 by 3. Now I3, V2 by 2. And then I4, V2 by 6 is equal to 0. Now you can take 12 as an LCM, right? V2 by 6 is equal to 0, V2 by 2, everything is fine. V1 minus 0, that is the V1 minus 14 divided by 4. Okay, perfect. Now it will become 3V1 minus 42 plus 4V1 plus 6V2 plus 2V2 is equal to 0. This will become 0, and then 4 plus 3 7 V1 plus 8 V2 is equal to 42. That is the second equation. 7 V1, that is the 42 is equal to second equation. Now we want to solve this. For example, this is the first equation, that is the second equation. If the first equation is multiplied with first equation and second equation. Now on the second page, watch this. Now we are having the two equations. Then if the first equation is multiplied with 7, it will become 7V2 minus 7V1 is equal to what? 42. Third equation. Add 2 and 3. When I am adding the 2 and 3, 7V1, 7V1 cancel. 8 plus 7, 15V2 is equal to 84. We are getting the answer? Yes, please tell me. What is the answer here? That is the question number. Yes, please verify what is the answer you are getting. Everyone, tell me where I have done mistake. Just this is the calculation. V2 minus V1 is equal to 6. Okay. Then this is the I1, this is the I2, this is the I3, this is the I4. V1 minus 14 by 4. Okay, that is correct. V1 minus 0 by 3. That is also correct. V2 by 2. That is also correct. V2 by 6. That is also correct. Then I have taken the 12 as LCM. Okay, 3V1 minus 42. Yes. Then 4V1 plus 6V2 plus 2V2. It is also correct. 3 plus 4, 7V1. And then 6 plus 2, 8V2 is equal to 42. That is also correct. Okay. Now, 1 minute. What you are getting the answer? I is equal to 2.8 ampere. I is equal to what? 2.8 ampere. How many students are getting this answer? Yes, means I have getting the right answer for this. Okay, we have to calculate the V2. Okay, no problem. This is the value. When I am adding these two, this is 8 plus 7, 15 V2 is equal to 7V1, 7V1 cancel, 42, 42, 84. That is the problem. V2 is equal to 84 by 15. 84 by 15, and that is the 5.6 volt, and then 5.6 by 2, that is the value of I. 2.8 ampere. This is the correct answer. 2.8 ampere. Now you have the value of the V2. You can put the V2 here. So what is the value of the V1? V2 here, then what is the value of V1? Minus 0.4 volt or 400 millivolt. 400 millivolt. Yes. So you have given the right answer for this question, that is the minus 400 millivolt. Now all are comfortable with the supernodal? Tell me. All are comfortable with the supernodal analysis. How to write the supernodal? V2 minus V1 is equal to 6, and then simply add this node, and we will get the two equation, and how to solve the equation, because very easy by using the elimination method, because there is some technical issue with the board. Overwriting is there, problem of the overwriting. Okay, and that's why. Okay then, good. So now guys, it is time to solve some homework. So just I want to give some homework, and then bhai, answers are available na, answers are available on what? Textbook. But please don't see the answer. First of all, solve the question. At the last you can see the answer, and then if you want, then you can post your detailed answer. For example, you can use what? Mesh analysis or nodal analysis or source transformation or any other method. If you want to post, then yes, you can post. Okay, silly mistakes. We are normally, Shreyans, we are doing the silly mistakes. Just to avoid the silly mistakes, try to solve this question. For example, watch this. If suppose I want to apply the nodal, what is this? V1 minus V2, 25 volt. V1 minus V2, that is the 25 volt battery is given here. First equation. And then second, again there is a voltage source, V3 minus V2. So what is the V3 minus V2 is equal to what? 5I. This is the V3 minus V2 is equal to 5I. And what is the I here? I is the branch current here. That is nothing but V1 by 2. I is V1 by 2. So I is V1 by 2. So you can write 5V1 by 2. It will become 2V3 minus 2V2 is equal to what? 5V1. And this is the equation. Or you can write 5V1 plus 2V2 minus 2V3 is equal to what? 0. That is another equation. Now you have got the two equations from what? This one. This is the first equation, and already you have solved this one. So this is the second equation. Now supernode. How we can apply the supernode? First, at this node, this current is let I1. This current is what? I2. This current is I1 and that current is what? I2. Okay. So you can write I1 plus I2 outgoing current. Then second, for this node, because here it is a branch, here already we have taken only I3. Then fourth, I4, right? And then what? I5. But what is the incoming current? I2. So you can apply the incoming current, or you have to consider just we want to write the KCL at this node, and at this node. Just watch this. I'm going to write I1 outgoing current. What is the outgoing current? I2. Okay. Then this is I3. This is what? I4. Write these nodes and try to solve this particular question, guys. So this is the homework for you. And at the next class, I will give the answer for this question. So you can also use the Cramer's rule, or you can also use the mesh analysis or nodal analysis, or what? Just a supernodal, because in supernodal directly we are getting the relation between these two nodes, and then finally you can apply. Then yes, try to write these equations, guys. Okay. Okay then. Now, if we are having, try to understand, if suppose we are having the relation between these two, V2 and V1, then we can apply the supernodal between these two, first of all. And then why, guys, what we can do, we can apply the supernodal this. So this is question is very, very important. Try it. If you find any difficulty, then please inform me. Now, do you want answer for this question? 3.14? 7.608. 7.608 volt. V2 is equal to minus 17.39. And third one is 1.6305. 6305. 6305. Okay. Figure number 3.14. So try to solve this question. Okay then, guys. This is we have, if you want to solve more question, if you want to solve the previous year question paper in a proper sequence, then you have to download BYJU'S exam prep app. Free papers are available, free mock tests are also available, India level mock tests are going on, so you can join. And if suppose you want to get your results, then leaderboards are available, how many number of participant is there, what is your rank, what is your score, you can see there, okay, on BYJU'S exam prep app. Then second thing, this is already we have started the crash course for you, that is the complete syllabus coverage for electronics branch as well as for electrical branch. Live classes, recorded lecture, study material, practice quizzes, mock test, everything available here, okay, and that is for electronics and electrical branch. For more detail, you can call at this number. Then this is my Telegram channel. Join this Telegram channel because I will upload the PDF of this session on that Telegram channel and go through the solution and try to avoid silly mistakes, guys, and make your own path. So this is my Telegram channel, Electronics by Sanjay Rathi. And finally, thank you very much for attending the session. Like the session, share the link of this session and subscribe our channel. Thank you.